for problem set 10 or homework set 10, question 13. I'm just going to give you some pointers on that, on how to solve it. So there's our building. We have this at 225 feet, theta, and then we have x here. So the question's asking you to find d theta dt when x equals 272. So the first thing you want to figure out is, well, what is theta when x is 272? Because we're going to need that after we derive. So solve for that value first, and then you're going to want to set up an equation that includes theta. So we're going to keep x as a variable. So we know that we have opposite and we are interested in adjacent as well. So that would be tangent. So tangent of theta is equal to opposite over x. And you want to leave that as x. You're just using this point of interest when we calculate the actual rate of change. So again, up here, you'll want to figure out what that value of theta is when x is 272. So then you would derive both sides with respect to x. So remember here, when you derive this, you're going to have whatever the derivative of tangent is, and you're going to also have to write in your d theta dx, because normally when we derive, just a plain old like y equals tangent theta, the derivative of y is 1, and then we have our dy d theta or dy dx. So in this case, the derivative of tangent isn't 1, so that's an important component to remember to keep in. And then you're going to want to derive 225 over x. So you're deriving with respect to x, so that does not get a d theta dx afterwards. So then you would solve whatever you get here for the derivative of tangent. So you would solve this d theta dx is equal to, and then you would have your derivative here and divide by whatever you have over here. And then at that point, you're just plugging in your values. So whatever you calculated here for theta, and you'll plug in this value for x, and you will solve. Make sure that your calculator is in radian mode. Or you could use Desmos, whatever is more convenient.